Hello, my name is Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 7, Section 3, titled Solving Systems by Elimination. By the end of this video, you will have reviewed methods for solving systems of equations using elimination. You will review system solutions by using addition, subtraction, and multiplying first to solve a system. You will also get a chance to look at a couple real-world problems. Please subscribe to this channel. It'd be very helpful. Thank you very much. Okay, so before we get started, I'd like to touch on a definition. It says elimination method. What is the elimination method? You can use addition and subtraction, property of equality, to solve a system by the elimination method. You can add or subtract equations to eliminate a variable. We'll look at that as we move forward. Okay, objective 1, adding or subtracting to solve a system. The addition and subtraction property of equality can be extended to state if A equals B and C equals D, then A plus C is equal to B plus D. If A equals B and C equals D, then A minus C is equal to B minus D. We've actually seen that in the past, haven't we? You can use the addition and subtraction properties of equality to solve a system of equations by the elimination method. You can add or subtract equations to eliminate a variable. Okay, let's take a look at one of those. Okay, example 1. Let's look at adding equations. How would we add equations to solve a system? So it says here, solve by elimination. So we're going to solve the system of equations right here. This 5x minus 6y is equal to negative 32, and 3x plus 6y is equal to 48. We're going to solve these in a way that we'll have a solution that will satisfy both of these equations. Okay, and make them true. So step 1, let's eliminate y. And why? Because the sum of the coefficients of y is 0. So if you're adding and subtracting, what do you want to do? You want to look, if you can start off, is there a easy way to get rid of one of the variables? And in our case, if we add these two equations, the 5x minus 6y equals negative 32, and 3x plus 6y is equal to 48, you see that we have the negative 6y and a positive 6y. So if we add these equations together, what are we going to get? Well, look down here. Elimination method, right? So we have 5x minus 6y is equal to negative 32, and we're going to add the entire equation to the top equation. And when you add that, you're going to get 5 plus 3x is 8x, and you're going to get negative 6y plus 6y is equal to 0y. And you're going to get negative 32 plus 48 will give you 16. This was using the addition property, right, of equality. And then when we solve for x, x equals 2. So we now have our x equals 2. So now we want to solve to eliminate the variable y to get to for solving that in either equation, right? So we have y. Now we want to get the y value. We have x. We want to now eliminate x, in essence, to get the y variable. So what are we going to do? 3x plus 6y is equal to 48. We just picked, it doesn't matter which one you pick. And then we're going to substitute where the x is, because we solve for x and it's 2. We can now put the 2 in for x in this equation right here. So now it's 3 times 2 is 6, plus 6y equals 48. That's our new equation is going to be right here. 6 plus 6y equals 48, because the 3 times 2 is equal to 6. Okay, we're going to subtract 6 from both sides, and when we do that, we're going to get 6y is equal to 42. Subtracting 6 from both sides. Now we solve for y, and we'll divide both sides by 6, and we're going to get y is equal to 7. So now we have x equal 2 and y equal to 7. So what that's telling us is that when x is 2 and y is 7, that will be the solution for both of these, right? So since x is 2 and y is the solution is 2, 7. Let's check. This is our solution, by the way, 2, 7. Let's check. Substitute 2 for x and 7 for y in either of the equations. Well, we have them both here. So if we substitute 2 for x and y, 7 for y. In this equation here, we have 5 times 2 is 10, minus 6 times 7 is minus 42, equals negative 32. Well, 10 plus negative 42 is 32. 32 equals, negative 32 equals negative 32. Let's try the other equation. 3 times 2, our x value is 2, is 6. And 6 times 7 is 42. Right? Because now the y value is substituted for 6y. 42. If you add 6 and 42 together, you get 48. And 48 equals 48. So we've checked it now. Both equations are solved. Okay? Good deal. Okay, example 1, check your understanding. So what if you've been with me before, you know what I'm going to ask right now. And if not, so here's what we want. I would like you to pause the video and try to work this on your own. Pencil and paper, work it out, and then when you come back, we'll do it together, okay? I'll stop so that you can pause. Well, before you do that, I'll even say 6x minus 3y is equal to 3, and minus 6x plus 5y is equal to 3. Solve the equation, solve the system. Okay, I'll wait. Okay, I'm assuming you've done that, and let's give it a whirl here. So right off the bat, we're going to look for what can we do to these equations to eliminate one of the variables. Well, by appearance, right off the bat, we can see that if we add these two equations together, the 6x minus and the minus 6x cancel each other. Well, that's wonderful. So what are we going to do? We're going to add these together, and we're going to get what? We're going to get, I'm going to delete this little arrow right now. I'm going to delete that. And if we add them together, we're going to get 0x plus 2y, because 5y minus 3y is plus 2y. And that's equal to 3 plus 3 is 6. Now we've got the x is gone, so now we can solve for y. If we solve for y, we're going to divide both sides by 2. And what are we going to get? We're going to get y is equal to 2 into 6 is 3. So y is equal to 3. Now we're going to substitute in either equation. It doesn't make a difference which one we choose. I'll pick the top one. So now I'm going to say we're going to solve for x this time. So 6x minus 3 and y is 3, all right, equals 3. And when to solve this, we're going to say 6x minus 3 times 3 is 9. Minus 3 times 3 is minus 9. And that equals 3. So now to solve for x, we're going to add 9 to both sides. 6x plus 9 minus 9 is equal to 3 plus 9, right? Just doing the work, carrying it out. So now we have 6x is equal to 12. And we're going to divide the 6 into both sides. 6 and 6. We're going to get x is equal to 2. So our solution is x comma y, and that equals 2 comma 3. And if we're going to check it just offhand, you can put a 2 in here. X is 2. So we got 6 times 2 minus 3 times y is 3, and that equals 3. So does 12 minus 9 equal 3? Yes, it does. 3 equals 3, right? Okay? Either equation, if you put that in, you're going to get the correct answer. Okay, example 2, we have a real world problem. This is going to be fun. This will be interesting. How do you solve this system? And what does a system mean? We're going to find out a couple of different pieces of information. And it's pretty nice doing this. Hold on one second. Okay, so let's read it here. Suppose your community center sells a total of 192 tickets for a basketball game. An adult ticket costs $3 and a student ticket costs $1. The sponsors collect $470 in tickets. Right here, it's $470. Write and solve a system of equations for the number of each type of ticket sold. So what they want to know is the sponsors collected $470 by selling adult tickets and student tickets. The adult tickets were $3 each. The student tickets were $1 each. They would like to know, what we were going to find out here is how many student tickets were sold and how many adult tickets were sold. All we know is the total number of tickets, and we also know the total amount of money, and we know what else we know. We know the cost of each ticket, and we know by thinking about it, of course, that if you add the number of student tickets and the number of adult tickets together, you're going to end up with 292, right? So let's see how we would solve this. So first of all, we're going to start off by saying, let's define something here. And what we don't know is we're looking for adult tickets and student tickets. So let's say that the number of adult tickets is A. We're going to let A equal the number of adult tickets. Okay? And we're going to let S equal the number of student tickets. So now when you see an A, you're going to think the number of adult tickets, and S will be the number of student tickets. Now then, we're going to say, let's relate we need two equations. We have two variables. You need two equations to solve a system with two variables. If you had three variables, you would need three equations to solve a system of three variables. Okay? So we have two variables. So we're going to solve a system with A adult tickets plus S, right here, A adult tickets plus S student tickets is equal to 292. We know that. We just talked about that. And we also know that the $470 that they earned came from selling adult tickets at $3 per ticket and student tickets at $1 per ticket. So if you multiply 3 times A and 1 times S, that being the number of adult tickets and the number of student tickets, you're going to get 470. So now we're going to solve this as a system. And we're going to do it by elimination. So first, what are we going to do? We're going to write our two equations. We're going to say 1 adult plus 1 S, 1 times A plus 1 times S is equal to 292. So that's the A tickets plus the S tickets equals 192. That's our first equation right here. Okay? And we're going to subtract from that over here, the 3A plus 1S, 3A plus 1S, right here, okay, equals 470. So there's our two equations. A plus S is 292, and 3A plus 1S is 470. And we're going to subtract it. And why are we just going to subtract it? Because when we do, as you look here, you see that I'm going to delete this little bit of markings I made here, so it's a little easier to see. When you subtract these, you have one here minus 1, because they're both positive numbers, so 1 minus 1 is 0. So we're going to end up with 1 minus 3A is negative 2A, because we're subtracting, and we have 0S plus 0S, okay, is equal to 292 minus 470, minus 178. Negative 178. So that's the new equation, so to speak, but it's in one variable. It's in variable A. So we can solve for A. So what is A? It's equal to 98 because this is 0 here, so you have the negative 178, and you're going to divide by a negative 2, and you'll end up with 98, positive number. And now we have A, and A equals, if I did it here, A would be like, say, the X value. So A, comma, right? And comma S. Let's just do it like that. So we're going to have 89, comma something. We don't know what the other one is yet. And then we're going to solve for the eliminated variable using either of the two equations. Okay, so we now know that A is equal to 89 right here. we're going to take our equation with the a, 1a, the a plus s is 192, and we know that it's 89 is a, and 89 plus s is 192. Okay, so now we're going to move the 89 to the other side by subtracting it, and you'll have the s is equal to 203. So we now know that the students bought 203 tickets, and the adults bought 89 tickets. So I can say now here, I could say 203. So that's like a solution, A and S. Okay? So that's pretty much it. So there were 89 adult tickets and 203 student tickets. And if you want to check it, is the solution reasonable? Well, let's look. The total number of tickets sold is 89 plus 203, and that equals 292. The total sales are 3 times 89 and 1 times 203. $3 for the adults and $1 for the student. And when you add those up, you're going to get $470. The solution is correct. Okay, example 2, check your understanding. So again, you know that I like you to pause the videos on these check your understanding. Try it yourself, and when you come back, we'll work it together. But before you go, I'll read it with you. Your class sells a total of 64 tickets to a play. A student ticket costs $1, and an adult ticket costs $2.50. Your class collects $109 in total ticket sales. How many adult tickets did you sell? How many student tickets did you sell? That's what we want to know now. So just like on the previous slide, what are we going to do? First, we're going to have to come up with two equations. One will probably have to do with the total number of tickets sold, and the other one with the total cost. So we can relate these costs to numbers of tickets together, right? So let's go ahead and say, let's let, as we did in that other in the other slide, let's let student tickets, okay, so let's let S equal the number of student tickets. Okay, let's let A equal the number of adult tickets sold. Right, these are both sold. So we have the A. So what do we have an equation now, right? So what is that equation? We have S plus A is equal to total tickets, right? I'll say total tickets sold. Oops, sold. Okay, good enough. So there's one of our equations. Now, what are the other ones? So it's student tickets are $1, so 1 times S, plus the adults are 250. 250 times A is equal to what? It's equal to the total sales total. Okay, we got that. So that's first equation. Here's the second equation. The total tickets sold, oh, I forgot to write it in, I'm sorry, is what? 64 tickets, and total tickets sold, it's $109. So now we have our equations. The equations are just that. It's S plus A is equal to 64, and 1S, I'm putting that there because it's $1, just so to remind you that it's $1, plus 250 A is equal to 109. So now we want to eliminate. So what's the best thing to eliminate? Well, isn't this 1S is also true, correct? So let's eliminate the S. So in order to do that, we can just subtract the two equations, right? So let's subtract them. So I'm going to put a parentheses around this. And we're going to end up with a negative sign right here. And when we do it, I'm going to get 0s, and this is 250a, 2.5a. It's 1a minus 2.5a, and that equals negative 1.5a. Okay, and then that equals what? You have 64 minus 109, and that equals negative, where is it right here? Negative 45. Okay, so now we have this. So now our new equation is, we have the a term, right? So we have negative 1.5a is equal to negative 45. So we're going to divide both sides by negative 1.5. So we'll say negative 1.5, negative 1.5, and then the solution then. So we have, over here we have a equals 45 divided by 1.5 is 30. So A is 30, and now we want to find, so that's the adult tickets. There were 30 adult tickets sold. And now let's substitute back into either equation. It doesn't matter which one, you can choose either. Let's pick the top one. So I'm going to say A is equal S, so I have the new equation is S plus 30 is equal to 64. So if I subtract 30 from both sides, I'm going to have S is equal to 34. Okay, so there are 34 student tickets and 30 adult tickets. And there's our solution. So could we write it out? No, they don't want us any. That's all they need is the number. So if you look at it as an ordered pair, it would kind of be S, comma, A, and then the answer would be S would be 34, comma, 30. Okay, as your solution. Okay, objective 2, multiplying first to solve systems. So from examples 1 and 2, you can see that to eliminate a variable, its coefficients must have the sum or difference of 0. Remember, we just added or subtracted the equations so that one of them, like the y or the x term, would disappear, right? So that's what you're trying to do, is get rid of one of the terms so you end up with one variable left, and then you can solve for it and then plug it into the equation and then solve for the other variable. Sometimes you need to multiply one or both of the equations by a non-zero number before you can do your addition and subtraction. And by doing the multiplication, then you bring the two, at least in one of the variables, you bring them equal to each other, or at least opposite each other, so that you can add or subtract them. So let's take a look at that. Example 3, multiplying one equation. Solve by elimination method. 2x plus 5y is equal to negative 22. And 10x plus 3y is equal to 22. So step 1, eliminate one of the variables. So we're going to start with the given system here. Okay, first we're going to try to eliminate one of the variables. So the given system is right here. It's the problem that they told us about. Here's the given system, and we're rewriting it right here. Okay, so this is the given system. Then prepare for elimination of x. We're going to do the x first and get rid of the x by multiplying the equation by 5. Well, what do we get? When we multiply the first equation, the entire equation, by 5, and leave the second equation as it was, okay, they're the same still, you're going to get what? You're going to get 10x, 2x times 5 is 10x, 5 times 5 is 25y, and 5 times negative 22 is negative 110. And now you've still got your other equation. We're going to subtract that. We're going to subtract that other equation. Let me get this little mark off of here. We're going to subtract it. So we have parentheses around the entire equation because we're going to subtract every term in that equation. So to start off, we're going to subtract from 10x, we're going to subtract 10x. and we end up with 0x. 25y minus 3y is 22y. And 110 minus 22 is negative 132. So now we have an equation in one variable, y, and we can solve for y. And when we do that, over here, we're going to say 22y is equal to negative 132. And so when we divide both sides by 22, we're going to get y equals negative 6. So now we have our numbers. We have our x, oh, excuse me, we have our y, right? We have our y, which is negative 6. So now, for step 3, we're going to eliminate the remaining variable. We're going to eliminate the variable we just solved and solve for the remaining variable. So it says 2x plus 5y is equal to negative 22. That's just a standard equation from the top. But we're going to plug in our y variable. We ended up with 6, negative 6. We're going to plug it in right here in the equation, negative 6. Okay, so we're going to say 2x plus 5 times negative 6 is equal to negative 22. And then from there, we're going to say 2x is equal to, or plus 5 times negative 6 is negative 30. So it's 2x minus 30 is equal to negative 22. And now we're going to divide both, we're going to move the 30 to the other side. So it's going to be 2x is equal to 8 because 30 minus 22 is 8. And now we're going to divide both sides by 2. And right here, we divide by 2 on this side and divide by 2 on this side, and we get x equals 4. Our solution is 4, comma, negative 6. Okay? There's x is 4, and the y is negative 6. That's our solution. Okay, example 3, check your understanding. So solve by elimination, and we're going to use, what are we going to use in here? As we did before, we're going to be using multiply, right? Multiplying. So what are we going to multiply? Well, what's easiest to get rid of? 2 times anything and 7, that doesn't get you anything. But 15 and 5 is good because you can multiply 5 by 3 and get 15. That's a good start. The 17 and 32 doesn't help you. Okay, so let's multiply. We're going to start with our system here. And we're going to multiply the lower equation here by 3. So I'm going to do it. I'm going to start right here. I'm just going to say 3 times this entire thing, right? And what is that equal to? We're going to end up with negative 2x plus 15y minus 32. And that equals 21x minus 15y is equal to 17 times 3 is going to be 51, positive 51. And we're going to add these two together, aren't we? Because this is a negative, right? So we're going to add these together. So 21 plus 2 is 19x. And then it's going to be plus 0y because they cancel each other. And that's going to be 51 minus 32, right? So 51 minus 32, and let's see, is going to be 19, right? 50 minus 30 is 20, and the ones will give us a 19, right? Because we're going to subtract 2 from the 1. So now we have what? We have 0y. So that y is gone. So now we have 19x is equal to 19. So x is equal to 1. So we got the x value. We're going to say our x is 1. What we're looking for now is the y term. So we're going to substitute the x into either of these equations. It does not matter which one we choose. Which one's the easiest? Well, let's do the other equation now. So now we're going to do, and substitute here, we're going to say negative 2, times 1 plus 15y is equal to negative 32. Okay, so now we're going to take care of this multiplication. We're going to get negative 2 plus 15y is equal to negative 32. And now we're going to add 2 to both sides to get rid of the 2 and get y by itself. So we're going to have 15y is equal to negative 32 plus 2, okay, is 30. And y then, dividing both sides by 15, y is equal to 2. I'm sorry, negative 2. I didn't carry the negative, right? So it's negative 2. So when we added the positive 2 to negative 32, we got negative 30. And now y is equal to negative 2. So up here, our solution is negative 2. So 1 comma negative 2 is the solution to this system. Okay, example 4, real-world problem solving here, so this will be fun. Suppose your class sells gift wrap for $4 a package and greeting cards for $10 per package. Your class sells 205 packages in all and receives a total of $1,084. Find the total number of packages of gift wrap and the number of packages of greeting cards sold. So how do we do this? Well, first, we have to find some variables. We have to define some variables that we can use for our equations, right? So what do we want? Let's let W be the number of packages of gift wrapping, right? W for wrap. And let C be the number of greeting cards, C for cards. So when you work on the problem, you'll know which one you're dealing with the wrapping or the cards. Okay? So now that you have that, let's relate some of the words in the sentence up here, or the definition of the problem, and create some equations from it. Well, what does it say? It says that we have packages, W packages of gift wrap, and C packages of cards. Okay, we know how much each are sold for each. And it says that we have 205 packages in all. So, so that would mean that if we took the number of wrapping card packages plus the number of cards packages and add them together, we should get 205. The sum total of the number of gift wrap packages plus the greeting card packages will equal 205. And then each one of these packages, the packages of gift wrap are $4 right here per package, and the cards are $10 per package. So we can say 4 times the 10, because we're going to want to eventually know how, not 4 times W, because we're going to want to know how many packages of gift wrapping we sold at $4 a piece. And then we can say plus $10 per each package of greeting cards. So 4 times W plus 10 times C, 4 times the number of wrap packages, plus 10 times the number of card packages is going to equal $1,084. So now we have our equations, we have all the facts. What are we going to do? Let's eliminate one of the variables. And to do that, we're going to start with the given system. What are the systems? Here they are. Right here, this is the first system here, and here's the second system equation here. So the given system is W plus C, here, W plus C is equal to 205, and 4W plus 10C is equal to 1084. So now we have to eliminate one of the variables. We started with the given, now what do we do? Well, to eliminate one of the variables, we have one variable, the W is 4W, and we have one of the W's is 1, and the same thing would work for the C, but we're going to choose, well, let's eliminate the W because it 4 times W on the top, okay? It will make 4W minus 4W on the bottom, right? So 4W, 4 times W plus 4 times C plus 4 times 205. And when you do that, you get right here, you get 4W plus 4C is equal to 820. So what are we going to do? We're going to subtract one equation from the other. So now when we do that subtraction, the 4 minus 4 is 0W, and 4 minus 10 is negative 6C. and 820 minus 1084 is minus or negative 264. Just subtract them. Remember, you have to subtract the entire every term in the entire equation. Just like when you multiplied each term by 4 over here. You have to subtract all the terms here. So now that you've done that, you've now come up with an equation for C. And you have solve for C, the step 2. It's negative 6C is equal to negative 264. That came from right here over here. Negative 6C is equal to negative 264. And when you solve for C, you're going to divide both sides by negative 6, and you're going to get C is equal to 44. Well, now that you know what C is, you can substitute it back in either one of your equations, but pick an easy one. Let's pick the one where C has a coefficient of 1, and we can just say W, in this case, W plus C, or W plus 44, is equal to 205. Once we've done that, we can now solve for W. W is equal to 205 minus 44 is 161. So the class sold 161 packages of W, gift wrap, and 44 packages of C, the greeting cards. Okay, good job. Okay, example 4, check your understanding. This is another little real world problem that you're going to solve on your own. If you'd like, I'll read it to you first. Suppose your younger brother's elementary class sells a different brand of gift wrap, which costs $2 per gift wrap package, and the cards which cost $5 per package. His class sells 220 packages in all and earns a total of $695. Find the number of each type of package sold. So this is just like the previous slide, right? So why don't you go ahead and pause the video, try it out. When you come back, we'll work it together. Okay, let's assume you've done that. And we're going to move on from here. So like we did before, the first thing we're going to do is we're going to define some variables. And these are the exact same variables we had last time, because the variables that we don't know is we don't know what the gift wrap W, right? How many gift wrap packages we had, and we don't know how many cards, the C, right? So we're going to let, just like before, W equal wrap packages, and we're going to let, and we're going to let C equal cards. Okay, we have that. Now we have to come up with our equations. So let's define the number of wrap packages plus card packages is going to equal 220. So I'm going to say W plus C, the number of gift wrapping packages plus the number of card packages is going to be equal to 220 packages in total. And we also know that the wrap packages are going to be equal to $2 per package, $2 per package, plus $5 per card package, and that's going to be equal to 695. So what that's saying is if you take 2 times every one of the gift wrap packages you sold, plus 5 times every one of the greeting card packages, and add that together, you're going to get $695. So now what do we need to do? We need to solve for, this is our system. Here's our system. We need to solve. So what do? We're going to multiply. We don't have any coefficients that are equal, so we can't just write up, subtract, or add to eliminate one of the variables. So we have to multiply. And it'd probably be pretty easy to either multiply the W by 2 to get a 2W, or to multiply the top equation by 5 to get a 5C, right? So we can subtract. Well, let's do the W. Excuse me. So I'm going to say let's multiply 2 times W plus C equals 220. And then 2W here, 2W plus 5C is equal to 695. So all we did is we put parentheses around our upper equation, and we're going to multiply each term. And when we do that, I'll go over here. If we do that, we're going to get 2W plus 2C, and that is equal to 440 because we multiplied everything by 2. And the bottom one equation doesn't change, so we still have 2w plus 5c is equal to 695. Nothing changed there. So now what can we do? We can subtract these two equations to get rid of the w's, right? So I'm going to put a parentheses around here and say we're going to subtract it. So when we do that, what are we going to get? We're going to get 0w. So the w is gone. We're going to be remaining with a c. And 2 minus 5 is minus 3c is equal to, excuse me, 440 minus 695 is negative 255. Okay, so now our c, we can divide both sides by negative 3. We'll get c equal to 85. Now we have c, we can go back and substitute the c back into one of our equations up here to solve for the other variable. We might as well pick the one we originally used. We can choose either. It does not matter. So, and the easiest is going to be the w and the c equals 220. So I'm going to say, now I'm going to say w plus c, which is 85, is equal to 220. And I'm going to solve for w. So w is equal to what? I'm just going to subtract 85 from each side, and I'm going to get 135. So there's our answer. Our answer is C equals 85 and W equals 135. The card packages, they sold 85, and the gift wrap packages, they sold 135. Okay? Good job. Okay, example 5, multiplying both equations. So this is probably the most complex way you can think of it, right? In our case here, or in the previous cases, we were just eliminating one. We only had to multiply one equation to get the coefficients of a particular variable equal to each other. So you could add or subtract to make them 0, right? So sometimes though, in fact, probably most of the time, in real life, in order to get one variable to add or subtract it and get it to equal 0, you're going to have to multiply both equations by some number, different numbers probably, in order to make them, in fact, absolutely different numbers, in order that you can get that variable x or y or whichever common to each other. So let's take a look at one. Solve by elimination. 4x plus 2y equals 14. That's our first system equation right here. And then 7x minus 3y equals negative 8. That's our second system equation. So remember, step 1, it says eliminate a variable, okay? Eliminate one variable is what we're going to do here. So start with the given system. So here's the given system. 4x plus 2y equals 14, and 7x minus 3y is equal to negative 8. Yes, I just looked at it and checked it. It's correct. I wrote it down correctly. Secondly, now we're going to prepare to eliminate the y variable by multiplying the one equation by 3 and the other one by 2. Okay? So we're going to take, what are we going to try to do? We're going to try to get the y variable eliminated. That's this variable here. And so what do we have? A 2 and a 3. So if we multiply the top equation by 3, this will be 6y. And if we multiply the bottom equation by 2, we're going to have 6y, negative 6y. So we'll be able to add the equations, right? When you add them, you'll get plus 6y minus 6y equals 0y. Okay, so that's what's going to happen here. And then when you do that, you're going to end up, when you do the multiplying, finally, you're going to see in the last step way over here, you have 12x, which is 3 times 4x, plus 6y, which is 3 times 2y, and then 42, which is 3 times 14. And then the second equation is 2 times 7x is 14x, 2 times 7. 2 times negative 3 is your negative 3x, or 3y rather. And 2 times negative 8 is negative 16. And now we're going to subtract them because we managed to get the y variable a plus 6 and minus 6. And that'll equal 0y. When we do that, we're going to get 26x, 12 plus 14 x is equal to 26x, and 42 minus 16 is 26. Okay, so now we have 26x is equal to 26. Step 2, solve for x. Well, 26x minus equals 26. X equals 1. We divide both sides by 26. Now we have our x. We can substitute back into either of our original equations. Okay, so we're going to go back. Now we're going to say, let's pick the 4x plus 2y equals 14, the top equation. And we're going to substitute 1 for the x variable. 4x is now going to be 4 times 1 plus 2y, which is what it was originally, 2y, and equals 14. So now we have 4 plus 2y equals 14. Well, we're going to subtract the 4 from each side. We're going to get 2y equals 10, 2y equals 10, and divide both sides by 2. Y will be equal to 5. There's our solution. X equals 1. Here's our 1 right here. The solution is parentheses 1 comma 5, close paren, and y equals 5. And here's the solution right there. Okay, example 5, check your understanding. I'll read the problem. Just eliminate, solve by elimination. And we have two problems. 15x plus 3y equals 9, and 10x plus 7y is equal to negative 4. 15x plus 3y is 9. 10x plus 7y is equal to negative 4. We're going to pause the video, I hope, and you're going to try this on your own. Eliminate one of the variables by multiplying. You're going to find that you need to multiply both equations by some number each in order to eliminate the first variable that you're going to go hunting for. And you can eliminate either one. It does not matter which one of the variables you eliminate. Just pick one and go for it. Okay, I'll wait for you. Okay, now that you're back, I'm back, we're all back here, so let's go ahead. 15x plus 3y equals 9. 10x plus 7y equals negative 4. Well, you could have picked the x. Had you picked the x to eliminate, you could have multiplied the 15 by a 2, or the top equation by 2, and you would have had 30x. And you could have not multiplied the bottom equation by 3, excuse me, and got 30x. Or you could have picked y. You could have multiplied the top equation by 7 and got 21, and the bottom by 3 and got 21 for the y's. Well, what happened, the problem though, 7 times 15 gets to be a big number. 7 times 9, it might be easier to go with a smaller number. And here you're going to be multiplying. Let's go with x. So what will we do? I'm going to say, I'm going to multiply the top equation here by 2. So I'm going to say 2 times 15x plus 3y equals 9. And then I'm going to multiply the bottom one here by 3. So I'm going to say 3 times 10x plus 7y is equal to negative 4. Now multiply them out. I'll go over to this side multiplying them out. 2 times 15 is 30x plus 6y equals 9 times 2 is 18. And then 3 times 10 is 30x plus 7 times 3 is 21y. And that equals negative 12. Now we're going to draw a line here. And what are we doing? We're going to have to subtract these two, right? So we're going to subtract the bottom from the top. And then when we do that, the x's will disappear and you're going to have 0x. And now you're going to have what? You're subtracting 21. 6, you're going to subtract 21. So that's going to give you minus 15y. And that equals what? 18 minus a minus 12 is what? 30? 18 and 12 is 30. Okay? 18 minus a negative 12 gives you 30. Excuse me. So now you have y by its y. You're going to have to get it by itself. We're going to divide both sides by negative 15. So we're going to have y is equal to 30 divided by negative 15 is negative 2. So we now have our y value. So we can come down here and pick either one of these. It doesn't matter which one you pick. But let's go ahead and pick the top one, I guess. So we're going to go 15x plus 3 times negative 2 is equal to 9. So 15x minus 6 is equal to 9. Excuse me. Having trouble with the throat today. 15x, going to subtract or add 6 to both sides. 9 plus 6 is 15. We subtract it on this side. 9 plus 6 is 15. Now to solve for x, we're going to divide both sides by 15. And you're going to get x equal 1. So our solution here is going to be 1 comma negative 2. The x value is 1. The y value is negative 2. Okay? Good job.